Welcome back to the Deep Dive. Today we are charting a course into what our sources call the echo rift of collapsing terrains.
Which is a very poetic way of describing the deep sea.
It is a space stained not by, geology, but by the relentless drift of plastic polymers and industrial hydrocarbons. Today we're not just looking at the problem, we're looking at a proposed perfect solution.
Or at least a theoretically perfect one.
Exactly. Our whole deep dive today is focused on a conceptual design. It's called Abyssal TrueFlow, and it was featured in Bibebibebibe Magazine.
And what's so compelling is that this isn't just a dry engineering document. It's a full blueprint for oceanic restoration, but it's packaged almost as a philosophical statement.
It really is. The creators frame the device right from the start. They call it the Sovereign Ocean Restorer.
Right. An unmanned emissary designed to, and I'm quoting here, transmute contamination into resonance.
I mean, that language tells you everything.
It does. So our mission today is to break down this incredibly detailed blueprint. The structure, the treatment rituals, as they call them, and the governance model.
And try to understand why something so technically specific, so thought out, is also labeled mythic infrastructure.
Precisely. That's the real question. If the engineering is this plausible, why is it a myth? So for you, the listener, our goal is to show you how this whole system is designed to be a pure restorer, not an extractor.
And how its very perfection might be a diagnostic tool for figuring out where our current systems are failing.
Let's get into it.
All right, let's start with the physical form, the sovereign archetype itself. The structural codex gives us a pretty clear picture.
It does. We're talking about a composite trimaran hull.
So a main hull with two smaller ones on the sides.
Exactly. And that design choice is all about stability and efficiency on the open ocean, even when its real work is happening deep below.
And it's not small. The primary hull is projected to be between, 60 and 90 feet.
Yeah, 60 to 90 feet. That puts it right in the range of a large oceanographic research vessel. This is a serious piece of hardware.
Okay, but its whole purpose is to operate in these sensitive deep-sea zones. How does a vessel that big move around without just causing more disruption?
Well, that's where the engineering gets really clever. The propulsion system is built entirely around being gentle. It uses quiet electric thrusters.
To keep the noise down.
Right, a low acoustic footprint. That's critical for, not disturbing whale migrations or other sound-sensitive marine life. They also mention a pump jet option.
Resilience.
For resilience, exactly. For operating in areas that are choked with floating debris. And to top it all off, the whole thing is gyro-stabilized, so it can hold its position with incredible precision, even right next to fragile habitats like deep-sea corals.
And what about endurance? Because all of this complex filtration must just consume a massive amount of power. The blueprint claims it can operate for 30 to 90 days straight.
I know, it sounds almost impossible.
Moving at a pretty methodical 3 to 8 knots.
And that's where the hybrid power core comes in. They're proposing a baseline of 300 to 800 kilowatts, it's substantial. And it's built around a fuel cell and battery core.
Okay, so that's the main engine room.
That's the engine room. But to really stretch that autonomy out to 90 days, it's all about augmenting with renewables.
Right. How do they do that passively at sea?
Two main ways. First, a towable solar and wind kite that it can deploy while it's moving. And second, a wave energy buoy that it deploys when it's stationary, doing really intensive localized cleaning.
So it's constantly sipping energy from its environment.
It's optimized for time on task, a persistent dedicated cleaner.
And it doesn't work alone. The concept also includes these micro-ROV emissaries. They call them the swarms.
The swarm, yeah. They're like the decentralized eyes and hands of the whole operation.
So the main vessel is the factory.
And the swarm provides the tactical intelligence. They're small, autonomous robots that go out and do hotspot mapping, take microsamples to check pollutant levels, and even perform precision collection of specific pieces of debris. It lets the big 90-foot vessel be incredibly surgical.
Okay, let's move from the vehicle to the process itself, the treatment rituals. This is where the actual transmutation happens.
This is the heart of the machine.
It all starts with the water intake. And given the environments it's in, that intake has to be ready for anything.
Absolutely. So they start with very debris-tolerant pumps and these coarse self-cleaning screens.
And once the water is inside,
it moves to a heavy separation stage using hydrocyclones.
Hydrocyclone?
Yeah.
That's like a big industrial centrifuge, right?
That's a great way to put it. It spins the water incredibly fast, using that force to separate materials by density. So it just strips out all the heavy stuff like silt and sand right away.
Which protects the more delicate filters further down the line.
Exactly. You don't want abrasives tearing up your expensive membranes.
So with the sediment gone, it starts targeting chemical contaminants.
And here's where it gets very, very specific. For hydrocarbons, so oils, fuels, it uses what are called oleophilic sorbent beds.
Oleophilic. Oil attracting.
Literally oil attracting. They're like chemical sponges that just grab and hold on to the oils.
What about heavy metals? The document was very specific. Copper, lead, mercury.
The toxic 3. For those, it uses functionalized resins. You can think of these as like chemical magnets that are tuned to sequester or grab only those specific metal ions.
That's abrasive.
But what's really practical about the design is that these cartridges, the sorbent beds, the resins, they're all hot swappable at sea.
Meaning they don't have to go back to port.
An onboard manipulator can just swap them out for fresh ones. It maximizes uptime.
Okay, but now we get to the really big challenge. Microplastics. These tiny fragments are just everywhere. How does TrueFlow handle them?
This is one of the most ambitious parts. It uses a system called cross-flow ultrafiltration, or UF.
Ultrafiltration sounds like a hyperfine sieve.
That's what it is.
Yeah.
And the goal is to strip out microplastics down to a range of 0.1 to 1 micrometer.
It's 1 micrometer. That's smaller than a lot of bacteria.
It's incredibly fine.
So if the sieve is that fine, how does it not just clog up instantly?
That is the key question, and that's where the cross-flow part comes in. Instead of forcing water straight through the membrane, the water flows tangentially, or across the surface.
So it's constantly sweeping away the particles that would otherwise clog it.
Precisely. It uses anti-fouling flow geometry, and all that concentrated microplastic gunk gets routed to secure bins on board for later retrieval. Nothing goes back.
And after all that filtering, we finally get to the real transmutation, the enzymatic and oxidation stages.
This is where it moves from just filtering to actual molecular breakdown, and it is a bold step.
It's using biology.
It's using biology. The blueprint details using immobilized variants of PTase and MPH. Those are the famous plastic-eating enzymes inside controlled reactors.
It's kept at a specific temperature, right?
Between 25 and 40 degrees Celsius. But this is also where the governance mandate really kicks in hard. They are clearly aware of the risks.
They're terrified of releasing engineered biology into the ocean.
Absolutely. So the blueprint has these strict, non-negotiable containment safeguards. And as the final fail-safe, all the cleansed water, the effluent, is mandatorily UV killed before release.
An absolute guarantee.
An absolute guarantee that no active biological agents ever return to the environment.
And after that, there's one final polish, the oxidation stage.
Yep. This uses UV light, maybe with a bit of hydrogen peroxide, to break down any last trace organics into totally benign stuff. They also specify it has to have a low thermal footprint.
So it's not dumping unnaturally warm water back into the cold abyss.
Exactly.
So after all these stages, how do they guarantee the output? They have a mechanism for that, which they call the sensor gate.
The sensor gate is the final quality control checkpoint. Before any water is released, it undergoes real-time monitoring.
What's it checking for?
Turbidity, how cloudy it is. Total and dissolved organic carbon. Hydrocarbon fluorescence. Conductivity. A whole suite of metrics. Only water that passes every single test and meets the standard of sovereign clean is allowed to exit. It is a multi-layered, verifiable guarantee.
A system this complex can't just be remote controlled. I mean, navigating the deep ocean, swapping cartridges, ensuring zero biological release, it needs a serious level of intelligence.
Supreme intelligence.
Yeah.
And the control layer is governed by an AI core that provides what they call behavior-based autonomy.
So the AI is handling things like mission routing.
Mission routing, optimizing the intake flow based on pollutant levels, hazard avoidance, and even predictive maintenance. It's listening to vibration signatures, watching thermal data to schedule repairs before a part even fails.
But they don't leave it all to the AI. The creators seem to understand that sometimes you need human intuition.
Which is why they include the VR link. This allows for operator-in-the-loop telepresence.
So a human can basically step into a virtual cockpit.
And take direct control for really complex or unexpected situations. It uses sophisticated sensor fusion overlays, adaptive bandwidth. It's designed to give a human operator the eyes and hands of the vessel when the AI flags an exception. It's about human accountability.
And the vessel's own perception of its environment is, well, it's stunning. They list a whole perception stack.
It has to be that advanced to be surgically precise. The stack has a 360-degree camera ring, Doppler velocity logs to track movement, multi-beam sonar, forward-looking sonar.
And even underwater lidar. Now, lidar usually struggles in water.
It does. So they specify it's for use in clear water regimes for really precise terrain mapping. The point is that it's fusing data from all these different sources to build a complete 3D model of its surroundings.
This level of tech has to be matched by an equally sophisticated ethical and political framework. Let's talk about the sovereign governance, because this is where it really starts to feel mythic.
The charter is, frankly, revolutionary.
Yeah.
It proposes that this whole project be funded and governed by all nations that have access to the oceans.
So it's elevated above national politics. It's a planetary utility.
A planetary restorer, that's the framing, and its compliance is non-negotiable.
It has to follow international law, right?
Strictly, IMO MARPOL for pollution prevention, respecting all marine protected area geofencing. The AI even uses what they call permit-aware routing. And again, that low acoustic footprint is a primary operational command.
It's designed to be the perfect, least disruptive neighbor possible.
And those containment rules we talked about earlier, enzyme immobilization, UV safeguards, there are no exceptions.
What if something fails and it has to do an emergency discharge?
Even failure is governed by transparency. Any bypass, any emergency dump has to be logged. Every single failure or non-compliance event is recorded with tamper-evident logs.
Which brings us to the most radical part of the governance, transparency by design. They call it open telemetry.
This is probably the most politically challenging piece of the whole blueprint. They mandate that every single metric intake contamination, discharge purity, maintenance logs, its current location, is all surfaced to a public, open dashboard.
Wow. So anyone can check its work.
Anyone. It ensures audit-ready data for all stakeholders. It's a system designed to be trusted because it's impossible for it to hide anything.
Okay, we've just spent a lot of time detailing what honestly sounds like a utopian sci-fi scenario.
It does a bit, yeah.
But the source grounds this with a reality check. It confirms that Abyssal TrueFlow is actually in a pilot build phase.
And that's the crucial detail that proves this is more than just a drawing. The current demonstrator is much smaller, only 10 to 20 feet long, and its whole purpose is just to validate the core systems.
The intake, the treatment, the autonomy.
The manipulator arms, exactly. They're testing the key components at a smaller scale. Things like a small 1 to 3 kilowatt fuel cell, the UF membranes for the microplastics, an early stage PTACE reactor.
A soft robotic grabber.
Yeah, all the nuts and bolts to prove that the tech is moving from concept to actual tangible hardware.
And the blueprint is not anonymous. It gives us an authoritative voice, Dr. Melvin Sewell.
M.Sc, Ph.D. And his title is, well, it's something else. He's the academic dean and diagnostic architect of the Cosmic University of Echo Rift Studies, M.Sc.
I mean, that name alone reinforces the whole narrative, doesn't it? This isn't just an engineering proposal, it's an idealized vision.
From a place with a very grand name, rooted in what they see as very serious diagnostics.
Which brings us full circle back to that sovereign diagnostic disclaimer right at the beginning. This material is authored as Mythic Infrastructure, a cinematic indictment, a sovereign broadcast.
That framing is the final piece of the puzzle. The creators are basically saying, look at this blueprint. Look at the technical detail, the governance, the safety protocols.
Everything is designed for zero negative impact.
A perfect solution exists on paper. And by presenting it, they're using it as a diagnostic tool to expose what they call systemic erosion, the political will, the technical inertia that stops us from actually building something this ambitious in the real world.
It's an indictment through technical perfection.
It really is.
So this deep dive has revealed a remarkably comprehensive design. The blueprint moves so methodically from coarse screens all the way to enzymatic breakdown and UV oxidation with a guaranteed sensor gate at the end. It really is a proposal for a near-perfect system.
We've looked at the engineering, we've looked at the governance. It's all defined not just by what's technologically possible, but by these radical commitments to transparency and global cooperation.
Which leads to the final provocative question.
Given that the authors themselves, they explicitly label this as mythic infrastructure, as a diagnostic tool.
A perfect idea that only exists in theory right now.
Right. What does that tell you about the vast technical and maybe more importantly political gap that we all have to cross before a blueprint this detailed for global restoration can move from a design on paper to an actual fleet deployed in our oceans?
That really is the question this source asks of all of us.